everyone, my name is Narendran Rao. The title of my research is Study on Carbon Fiber Reinforced Polymer Optimization as Wrapping Structure at 90-degree elbow in piping using simulation. The author for this research will be myself, Narendran Rao, Dr. Amal Mubarak, and also Shakti Lechmanan. For introduction for this paper, pipeline we know is facing major issues such as deterioration in form of corrosion, dents, wearing, buckling, and gouging, which eventually result in leaking and rupture. The most crucial part in a pipeline have been identified to be an elbow component due to its complicated shape. Fiber reinforced polymer composite carbon fiber has been decided to be used as the wrapping material due to its characteristics which are low density, corrosion resistant, and various better mechanical properties. Pipelines play a major role in almost all industries. We know there are many pipelines in almost all the industries. Elbow component being the most critical component and vulnerable to rupture and also being most to fail. To increase the effectiveness and reduce the risk of failure in elbow pipeline, wrapping the defect area using carbon fiber polymer will be a better option, a solution. Composite material have been identified as to increase the effectiveness and to reduce the risk. For the lamination orientation and the thickness of carbon fiber reinforced polymer will be determined by using Solidwork simulation. There are three main objectives in this research. First is to investigate the properties of carbon fiber reinforced polymer as a wrapping structure on defected elbow based on different lamination orientation using simulation. To analyze the mode of the failure on CFRP wrap elbows on various conditions and to verify the optimized lamination CFRP structure on defected 90-degree elbow. All three of these objectives will be determined using the Solidwork software. For literature review, there are almost 21 types of corrosion failure involved in a pipeline. Examples are insulation failures, corrosion failure, wet insulation, group pipe failure, and interior pipe deposit. The most common repair solution is to replace it with new one. By introducing this wrapping method of CFRP, it will be we can remain the existing pipe by only wrap the defected area of a pipeline, especially on the elbows. In this paper, we're going to choose the type of elbow that we use for this paper would be long radius elbow, 90-degree, and it's butt welded due to the application in oil and gas pipeline transmission. Why elbow fail is normally due to excessive pipe mobilization and also its sensitive corrosion difficulties due to its functional role and complicated shapes depending mostly on welding operation. Erosion and corrosion is a complicated material loss mechanism that always occur due to a flowing fluid disrupt. So this is because why elbow fails is the most critical part compared to other fittings or other part of pipeline. When the fluid velocity is very slow, the corrosion will be dominating. When the fluid velocity is very high, the erosion will be dominant. And there's a study by Rahim that says the surface roughness was higher at the entry region of the elbow than those of at the middle and the exit region. There's other conventional elbow repair methods such as welding, epoxy fill repair sleeve, clamp repair method. But the downside of this repair method is like corrosion of ball nuts, post seal retention clamp, and also the welding due to the increase the temperature of base metal and the to the cool down, and it's cooled to the room temperature very quickly. Uneven cooling will reduce the load carrying capacity of welded structure. That means the weld beams, the welded part will not be strong enough and will change the strengthness of the material. Why we choose CFRP as our wrapping material? Because of its own characteristic and unique characteristic, which is high specific strength, stiffness, resist corrosion, and possess low density and good dielectric material. These are some of the advantages. As we know, for wrap a piping material, we need it to be lightweight, to be high corrosion resistant, high tensile strength, high fatigue strength, and also high modulus of elasticity. All of these unique properties made to wrap the defected area, so it won't possess more stress or more load to the defected area, but it will cover and it will increase the strength and stiffness of the material. This is the model of the elbow structure that we model using Solidwork simulation with the flanges. This is the putty or wrapper that designed to cover the defected elbow. So the lamination orientation and the thickness of each carbon fiber wrapper plies will be discussed later on. For, for the summary for this literature review, from all the past studies, the carbon fiber have not been used as a repairing method for elbows in pipeline. To optimize right lamination orientation and thickness on defected elbow had not been studied. The performance of CFRP as wrapping structure on elbows could be significant for this research. So this the methodology. So this is the parameter setup for elbow. Type of pipeline is going to oil and gas transmission, 90 degree, and is 10-inch elbow with the material grade of API 5L grade X65 carbon steel. And this is the parameter setup for carbon fiber reinforced polymer wrapping structure with 1600 density and 3.53 gigapascal. This is the defect area with 70 mm of extra dose at the extra dose location, defect area with 100% wall loss. It's considered like a pinhole on top of the elbow. The lamination orientation, we have 3 different degrees to be wrapped around the defected area: 0 degree, 45 degree, and 90 degree. 0 degree can provide axial strength and stiffness. For 45 is provide shear and torsional strength, and 90 degree transverse strength and stiffness, which is ideal for pressure vessel. So the pressure that the load that we're going to simulate will be ranging from 0.86 until 19.65 megapascal with different lamination orientation. There are two analyses that will be carried out in this research, which will be static analysis. This is to identify which is the correct lamination orientation for 90 degree defected elbow at extra dose location, to identify the correct thickness of carbon fiber to apply on defect area, and to compare the effectiveness of carbon fiber and also glass fiber. And for second analysis would be flow simulation to verify is it watertight, and to observe on the velocity, temperature, and pressure behavior in piping model, especially at the defected area. This is the static analysis that we generated from the simulation. As we can see, the left is the lamination orientation from 0 degree until 0, 45, 90, 45 degree with 8 plies. Then the maximum stress that had been generated for each lamination orientation, there would be 4 load applied constantly, which is 0.86, 1.97, 5.65, and 19.65 megapascal. And the lowest we got is for the lamination orientation 0 degree with 6 plies, shows the lowest in terms of stress, which is at 3.283 for 0.86 megapascal. When load of 0.86 been applied, 3.283 megapascal was shown as the maximum stress. It's shown it is the lowest for every load been applied. This is the sample of result we got from our Solidwork simulation. This is for the 0, 90, 45, and 80, 45 degree lamination orientation with 0.13 thickness mm, 8 plies. So we can see the load 0.86 megapascal been applied, and the maximum stress is 10.77 megapascal for this. This is the sample for a result, and this will be generated for each and every lamination orientation for 4 different type of loads that been applied. Internal pressure load. So what we got from this graph, we can see that 0 degree with 6 layers works best in terms of lamination orientation. The greatest stress was seen at the 0, 90, 45, and 80, 45 of 8 plies. So it can reduce the repairing time and cost of the CFRP wrapper, as it only be wrapped in 0 degree and with minimum thickness of 1.2 mm. From this simulation, we can know which one is the best and which is the optimum thickness. So why it 0 degree with 6 layers work best? Due to the 0 degree can provide more high axial strength, and due to the perpendicular to the angle of diagonal shear crack, because it is 90 degree elbow with 0 degree of wrapping method can provide perpendicular to the angle of diagonal shear crack, and also it can promote aggregate interlock, reduce the width of shear crack, and improve the ductility. There's no as we can see, there's a 0 degree with 8 plies, but it shows a slight higher than 0 degree with 6 plies. There's a research been done that no significant change in deformability was observed up to 6 ply configuration. The larger the number of plies doesn't mean it's increase in the strength, but it increase in the deformability. This mainly due to the load and also stress being applied to the defected area. This is the comparison of carbon fiber and glass fiber. Carbon fiber shows less stress compared to glass fiber when internal pressure being applied ranging from 0.986 and 19.65. This shows that carbon fiber exhibits greater material properties compared to glass fiber. For flow simulation, this is the parameter with 10 meter per second, 50 degrees Celsius and crude oil. This is to see whether the flow been disrupted or not. This is the velocity trajectory and pressure cut plot. There were no any big drop in pressure or significant change in the velocity. Only at normal cases, there change in velocity in any band of fitting in the piping system. This is the leak tracker. It shows there's no leak when the red line connected from one flanges to another flanges and the geometry is okay. So it shows the wrapper is sealed properly. For conclusion, CFRP possesses better material for wrapping 90-degree elbow compared to glass fiber. The carbon fiber with 0 degree with 6 plies shows the best lamination orientation for 90 degree at extruder's defect area. Flow simulation in this research showed that fluid was not disrupted and no change in pressure and velocity. Preliminary studies to justify the wrapping method of CFRP can be used in real-life application for any defects at elbow. This simulation could save cost and time due as simulation able to give lamination orientation with thickness. Thank you. That's all from me. Thank you so much.